Hello everyone, today we're going to be talking about characteristics of quadratic functions. So first, for just some review, we have several different parts of a quadratic, and remember we have our vertex form, which is f of x is equal to a times x minus h squared plus k. So the first important part of a quadratic function that kind of identifies it is the vertex, and the vertex is the highest or lowest point of a parabola. And if I'm looking at my vertex form, my vertex, if you recall, is h comma k, which we see up here. And so if I'm looking over at my parent function over here of parabola, this point right here would be my vertex. And then I have something called the axis of symmetry, or AOS for short. And this is the vertical line that goes through the vertex at the line of symmetry. In other words, it is the x value of the vertex. And so since the x value of the vertex is always h, that means that my axis of symmetry is just going to be x equals h. So if I'm looking here, my axis of symmetry would be this vertical line right here. Vertical line that goes through the vertex. And then I have something called the maximum and minimum, and this is the y value of the vertex. And so it's going to be a minimum when the parabola opens up. In other words, when a is greater than 0. And it's going to be a maximum when the parabola opens down. In other words, when a is less than 0. So here, this one would be a minimum, since it opens up. And kind of think of it, it only has a smallest value, and so that would be a minimum, and that's going to be at the y value of the vertex, so it's always going to be the k. So your graph would look like this. A maximum is when it opens down, so it'll look like this, and that's because it has a max value of wherever the parabola, the highest it can go. Domain, if for all of these quadratic functions, is always going to be the x's all real numbers. And that's because domain, if you recall, is all the possible x values that you can have in the function. And since these quadratic functions go forever to the right and forever to the left, it's going to cover all real numbers. Range, on the other hand, is going to be all possible y values. And so if I have a minimum, so if the graph is opening up, that means that my range is going to be y is greater than or equal to k. And that's because the smallest value would be that k value, so it's going to be y is greater than or equal to. If I have a maximum, then it's going to be y is less than or equal to k. So let's go through some examples of identifying these key features in a quadratic function. So for all four of these, we're going to graph the function, and then we're going to identify the vertex, axis of symmetry, max/min, domain, and range. So for this first one, I have y equals x minus 1 squared plus 3. First, I want to identify the vertex. And so remember that my vertex form is y equals a times x minus h squared plus k, where my vertex is h comma k. So here I see that my h is 1 and k is 3. So that means that my vertex here is going to be 1 comma 3. Axis symmetry, that is the vertical line that goes through my vertex. So if you see up here, the axis symmetry is always going to be x equals h. So that means that my axis symmetry here is x is equal to my h value, which is 1. Very important when you are typing in your axis symmetry, you do need the x equals in front because we are referencing a line. Next, I want to figure out my max/min value. So first I want to see, okay, is this going to be a maximum or a minimum? Well, I see up here that it's a minimum when the parabola opens up, or in other words, when a is greater than 0. Maximum when a is less than 0. Here, my a value is that number in front of my square term. I don't have a number in front here, so that means there's really an invisible 1. So I see that this is positive, so that means that this is going to be a minimum. And it's always going to be the y value of the vertex is going to be your min value. So the y value of my vertex here is 3. Next, I want to figure out the domain. Well, domain of all of these is going to be all real numbers, so I can just write all real numbers. And the range is going to be all the possible y values. So here, since I am opening up, this is a min, and so I know that means it's going to be y is greater than or equal to k. So that means it's going to be y is greater than or equal to 3. Okay, lastly, now I want to go ahead and graph this. So when I'm graphing this, I want to first go ahead and graph my vertex. So my vertex here is 1, 3. And draw in my axis of symmetry. And now I'm going to show you a little trick to go ahead and figure out your other points. So quadratic functions follow a 1, 3, 5 rule. And what I mean by that is if I'm looking up on this quadratic here, I see to get to my next point on either side, I go up 1 over 1. So I go up 1. And that gets me my first point on either side. To get to my next point, I go up 3. So 1, 2, 3, and over 1. And then to get to my next point from there, I go up 1, 2, 3, 4, 5. And that's going to be the case every time until we introduce a different a, which I'll show you on the second one. So here my a is just 0, so I'm following the 1, 3, 5 rule. So I'm going to go up 1, right 1, reflect it, up 3, over 1, and same thing on the other side. And then I can draw in my parabola. Okay, let's look at another one. So here I have y equals -2, x plus 3 squared plus 4. I'm going to go ahead and rewrite it so it's actually x minus my h in there. And so that means I have y equals -2, x minus -3 squared plus 4. So that means my h is -3 and my k is 4. So that gives me the vertex -3, 4. My axis of symmetry, that's always x equals h. So here my h is -3. So that means that x is equal to -3. Next, I want to find my max/min value. Well, I want to first determine whether it's a maximum or minimum. Here, my a is equal to -2, so it is a negative a value. So that means that this is going to be a maximum. And my maximum always happens at my y value of the vertex, so that's going to be 4. Domain is always all real numbers. And then my range, since this one has a maximum, that means it's going to be y is less than or equal to my k value, which is 4. So my first step to graph this, I'm going to go ahead and graph my vertex of -3, 4. And put in my axis of symmetry. And now I want to follow that 1, 3, 5 rule. But this time, my a value is -2 out in the front. So I'm going to multiply this 1, 3, and 5 by -2. So I get -2, -6, -10. So what that tells me, that instead of going up 1 over 1, I'm going to go down 2 over 1. And then for the next one, I'm going to go down 6. 2, 3, 4, and over 1. And then draw in my parabola. Okay, let's look at another one. So here I have y equals 1/2 times x plus 4 squared minus 2. I'm going to first go ahead and rewrite that with x minus in there. So I have 1/2 x minus negative 4 squared minus 2. So that means my h value is negative 4, and my k value is negative 2. So that means my vertex here is negative 4, negative 2. My axis symmetry is always going to be x equals h, and here h equals negative 4, so I get x equals negative 4. Next, I want to turn my max/min value, so I need to look at my a. My a value here is 1/2, which is positive, so that means that this is going to be a minimum, and it's going to happen at the y value of my vertex, which is negative 2. Domain is always all real numbers. And then for my range, just my y values. Since I have a minimum, that means it's going to be y is greater than or equal to. And so it's always going to be y is greater than or equal to k, which here is negative 2. Next, I want to go ahead and graph this. I'm going to graph my vertex first, which is negative 4, negative 2. And draw in my axis of symmetry. And then I want to follow that 1, 3, 5 rule. So 1, 3, 5. But then I need to multiply it by my a, which is 1/2. So I'm going to go up 1/2, 3 halves, and 5 halves. So up half, I have that right there. Then I'm going to go up 3 halves, which would be here, and then 5 halves. Same thing as 2.5. And then draw in my parabola. And so just to make a note on the range, you can see that the range here, just from our graph, is y is greater than or equal to negative 2, because the lowest point of my graph is at that negative 2, and we're going everything above it. Okay, go ahead and pause the video. I want you to work out this last problem, and when you think you have it, go ahead and press play. So this is the answer that you should have gotten for number 4. You should have gotten that your vertex was 2, 5. Axis symmetry is x equals 2. This one was a maximum because my a value, negative 3, is negative, and the value of it is 5, since that's the y value of my vertex. Domain, always all real numbers. Since this one is a maximum, my range is going to be y is less than or equal to 5, because that is the biggest that my y value gets. And then this is what your graph should have looked like. Since my a value is negative 3, I needed to multiply 1, 3, and 5 by that negative 3 to get my other points.